Hello students, so in this video we will see about other batteries which are left to see the working of those batteries. Right, until now we have seen the requirements of the storage, also we saw about the classification of the batteries, we saw about the working of the lead acid battery, also we saw about the 3 nickel batteries that can be used for the EV and HEVs. In this video we will further see about the batteries that are needs to be used, or we can use it in a HEV or EVs as well. So in this video we will see about first the Zinc-air battery. Now in case of the Zinc-air battery, the zinc is connected at our positive electrode, that is zinc metal, and the second electrode will be of air. Right, that air will be unidirectional flow or bidirectional flow of the air will be used in case of the air electrode, which means one plate will be attached from which the holes will be created. From that holes the air can be accessed whenever the discharging and charging effect is required. So the advantage of the air battery is that the air electrode will be infinite, right? It will not be depleted, it will not be overcharged, right? So air electrode will be there. The zinc electrode can be depleted, but the air electrode, one of the electrode will be used as a infinite source, right? Air is available and that can be used as an infinite source, right? So the air is used as an electrode, also the zinc is used as an electrode. Now the separator will have to be provided in between them, otherwise the air and zinc will mix from the start. The air electrode is either unidirectional, which means the air can flow only in one direction, or it can be used as the bidirectional flow as well. The chemical reaction will be very simple, that is an Zn plus O2, that is 2ZnO. So air is used as a positive electrode and zinc is used as a negative electrode, and the electrolyte will again be the same, that is aqueous KOH, that is potassium hydroxide, or we can also use a saline water in this case as well, right? Only water can be used if we are using an electric charging method. Now the air batteries can be used as a mechanical charging method as well. In the case of the mechanical charging method, the zinc electrodes will be removed by an automatic robotic method. That zinc electrode will be put on a mechanical charging method from which the zirconium will be created, and after the zirconium again the zinc will be restored, and that zinc can again be used in the battery. So the disadvantage of the electric charging in case of the zinc, which is nickel zinc battery, in which I said that the zinc is depleted and the shape of the zinc is changed. That disadvantage will be removed if we are using a mechanical electrode in case of the Zinc-air battery. So that mechanical charging method can be implemented in case of the Zinc-air battery, and it is better than the electric charging if we are using the air batteries. The another usage or another example of the air battery is an aluminium-air battery. Now the use of aluminium is done because it is the very easily available and it is available in abundance in the atmosphere, or we can say in the Earth's surface as well. So aluminium is used because of the reason that it is cheaper, it is easily available. Also, the aluminium is used as a negative electrode and our air electrode is used as a positive electrode. So in this case, you can see that simple example of how aluminium-air battery is arranged. In case of the aluminium-air battery, you can see that the separator that is being provided in between those two electrodes, the aluminium as a negative electrode and air electrode that is connected as an air supply, that is negative electrode. Now in this you can see two things, that is air in and second one is air out, which means that this source is an bidirectional air electrode source, which means it is supplying air during the charging and discharging. Both the times the air is being supplied to and fro in the system of the negative electrode. The chemical reaction, you can see that aluminium plus oxygen plus H2O, which gives us AlOH3. Now again in this case the electrolyte will be aqueous potassium hydroxide. From that the H2O will be taken for the chemical reaction during discharging and charging process, and this is simply how the aluminium air battery works. Here in chemical reaction you can see that the charging process is not seen, which means the arrow is only one directional. In the case of the aluminium air battery, the charging can only be done with the help of the mechanical procedure, right? As I have told you earlier that in this case the mechanical charging can only be done. For that the aluminium electrodes will have to be taken out. That electrodes will be done mechanical charging on that. So aluminium will be restored in that, and again it will be put in the battery as well. So this is simply how the aluminium air battery is used, but it can only be used with mechanical charging, and electrical charging is not possible in case of the aluminium air battery. The next segment of batteries are sodium beta batteries, right? The sodium that is being used as a sodium liquid, right? And the beta source is for the electrolyte that is used with the sodium, that is beta alumina ceramic. That beta alumina ceramic is a solid material. So in this case the electrolyte will be solid material, but the two electrodes, that is negative and positive electrodes, will be in a liquid form, right? The first one is the sodium-sulfur battery. So in the sodium-sulfur battery you can see that sodium is used as negative electrode, which is in a liquid form, and also sulfur that is being used in case of the positive electrode is in case of the liquid form as well. The beta alumina that is used as electrolyte is a solid. In that you can see that in tube form it has been used in the battery this time. So you can see the chemical reaction below part is that sodium plus sulfur gives us NO2SX. Now the value of X will depend on the content of the sulfur that is being available during the discharging and charging process, right? It varies from 2.7 to 5. The value of S varies from 2.7 to 5. So this is how the sodium sulfur battery works, or we can say one of the sodium beta batteries works. That sodium sulfur batteries has a good advantage. It has a good specific energy, specific power as well. Second of the sodium beta batteries is the sodium and metal chloride battery. Now in the case of the sodium metal chloride batteries, you can see that first the positive electrode is either porous nickel or either Na-NiCl, right? Nickel chloride. The nickel chloride or the porous nickel material will be used as a positive electrode. In the case of the negative electrode, the liquid sodium is used. That was earlier using sodium sulfur battery. In that case, the negative electrode is same liquid sodium, but in case of the positive electrode, either porous nickel or porous nickel chloride is used. Now the difference is that here we require two electrodes. One is NaCl4, that is sodium aluminum chloride, and the second one that was earlier used is beta alumina separator. Right, it is used as a separator bit, but it also works as an electrolyte in this case as well. Now sodium aluminum chloride is required for the porosity or for the proper discharging from the nickel towards our sodium, right, that assists the ions flow during the nickel and sodium flow, right. So you can see that the chemical reaction in case of the NiCl2 plus sodium, that gives us the nickel and sodium chloride. Also the FeCl2 can be used in place of the NiCl2, which gives the same value, but the voltage of the nickel chloride battery is better than the ferrous chloride batteries. The name of this battery or the sodium metal chloride battery can also be known as a zebra battery, right, because of the zebra pattern of the battery, which gives us the stripes of the two electrodes and two electrolytes. Next we will see about the lithium polymer battery. In the case of the lithium polymer battery, you can see here that we are using a lithium as an negative electrode, which is lithium foil which is used, and also as the positive electrode we are using an vanadium oxide, or we can use any polymer material, right. For the electrolyte, a thin solid polymer will be used as an electrolyte. The working of the lithium polymer battery will be again similar to other batteries as well, that is Li plus M/O2, that is metal oxide. In the case here we are using vanadium oxide, which gives us the lithium metal oxide, the combination of all three. The electrolyte will be thin solid polymer, which gives us the electrolysis process in case of the lithium and in case of the vanadium oxide. So this is how these batteries work. Now we have only left with one batteries that needs to be learned, that is lithium ion battery, and that lithium ion battery is the most widely used in our electric vehicles and hybrid electric vehicles right now. So that battery will be learned in the next lecture. Until then, thank you so much.